say it again. The original function goes positive both directions, so the y goes positive as the x goes to the right. The reflected function, the x still is positive because I can't take the square root of a negative number in the real number system, but I can get an answer out that's negative if I multiply it by a -1. So that y's go negative as the x is approaching positive infinity. The functions are reflections of each other, and we talked about this is what the picture looks like. The original square root function goes upward and outward, and the reflection goes downward and outward. Okay, so everybody's done with one. It gets simpler after that. That was just it. That was the graph one. We'll have graph ones later, but right now we're just talking function transformation. If you remember A, that's a vertical multiplier. It's not there. B, that's a horizontal multiplier. That needs to be taken the reciprocal of to talk about. And then H is 0 in this case. K is what's being added outside, so we go up because 6 is positive. Now, be careful not to use my numbers, all right, for your number 2. See where I got matchy-matchy? Do I need to get a little bigger, you think? Whoops, wrong direction. How's that? Is that bigger, easier to see? Okay, remember we have to flip the 1 over b. This is 1 over b. B is 3, okay? Now here, remember when we stretch vertically, we don't make the units negative. We just say it's what's being multiplied outside. We reflect, if I'm multiplying outside, it's across the x-axis. And then depending on what this drop-down menu is, which number am I talking about? Up or down, that's the 4. So it's going down by 4. And inside is the left or right. It looks positive, but it's a left move because it's a plus. It's subtracting a -3, okay? That's why it's left 3. Does this ring a bell? I hope you're feeling like you and the graphs are friends, frenemies, right? You don't like to do them, but you can. Thankfully, my numbers are different, so you know what numbers I got my ideas from, and you should know that too. Correct? This is familiar territory. We're just working with the square root function that has a boundary on its domain. Okay, because the 1/3 is outside, it's a vertical compression, and we don't take the reciprocal of A. A is what it is, and it's smaller than 1. That's why it was a compression. Then we translate what direction. It looks like it's right, and then it's the 1 inside, because the template has x minus h, so h is a positive 1, and then it goes down the outside number of 3. So that's why there's so many, because these go quickly. I hope you're seeing that, why there's so many, 17 of them. Just want to practice our understanding of transformation of graphs. That's one of the ACT standards, one of the college and career standards. Yes, okay, I'm multiplying inside, so that's a horizontal compression. I'm talking about this guy, and I have to take its reciprocal for it to be the factor that compresses, okay? Compress means I'm multiplying by a number less than 1 right here. Remember, we don't have a negative on the factor. The negative comes with the reflection. It's on the inside, so I'm changing the x values. Therefore, it reflects across the y-axis from right side to left side. Then there's only one translation. It's to the right. And it's 2 as well, right here, the h guy, right here. So its square root function would start at 2, 0 if you drew it as a graph. It's all a code. What you see is what I see. Complete the description of the domains and range using set notation. All right, they got it all ready for you. You just got to know what the domain starts at. If I put a 0 here, my domain, my number underneath would be negative, and that's a no-no. I've got to have it start somewhere where it equals 0, not before 0. That's not allowed in under a square root. So what would make x minus 7 0? H. Right? H is 7. Then what would, the range is both steered by the k number. What's being added outside here? If you don't see it, it's the number 0. Remember, whatever is out here that you don't see is supposed to be added. So invisible addends are 0, invisible multipliers are 1. It's got to be 7 underneath. And then it would start where k is for the range. Okay. H and k. Domain is H, range is k. Where did I get those numbers? Okay. -2 makes that 0. That's just a multiplier. So it doesn't, all it does is make the numbers either go up faster or go out faster. This one is the 2 that makes it, the range move up. Okay? Now, what if that multiplier was negative? What happens then? Oh, look, there's a negative number, but no multiplier. Right here, the domain, it still has to be a -6. But because this multiplier in here is a negative number, I've got to go 2 negatives multiplying. Therefore, this switches to less than or equal to. So when there's a negative multiplier, I got to have another negative multiplier so I don't, have imaginary numbers for answers. 2 negatives make a positive, therefore that makes sense. You're saying, well, I don't care. They wrote that in there for me. Who cares? But you're going to have to write this in, in the following problems. So that pay attention. This happened because there's a negative multiplier. Now this one comes from that number. Okay. So y would change only if there was a change outside. So y is still greater than or equal to 2. So the curve would still be going up, but the x would be going to the left. So the domain comes from h, which is 3. The range comes from, take the negative with the number. And then right here, this multiplier made the range go less than. Because if I add a negative number to a negative number, it's going to get less and less and less as my negative numbers grow. That's why that switched. Okay, we'll do one more. We get to select the graph from the parent function, describe the domain and range using set notation. So what's going to give you, and I don't think I can type on here, what your graph is looking for is that the original beginning of your square root function goes up 5, and then it reflects across the x-axis. So this guy went up 5, but it reflected across the y-axis. It flipped across this axis here. So A is not the answer. B, it went up 5, yay, and it flipped across the x-axis. So if this one was originally here, it'd be going down like that. So if you flip it and then you move it up. So B is my answer. You can find that on your choices. Okay, C is out because it is going to the left, not going and down. So C, it got like flipped twice. And D, it went down 5, and it was supposed to go up 5. See the plus 5 here? And then down here, this is where you got to do the greater than or equal to. So let me go back up. Let me get zoomed in here. Okay, on my transformed function, look how my directions, you see how my x's are still going positive? And they started at 0 because there's nothing being subtracted inside here. So it's 0, 5 when this thing starts. So x is still greater than or equal to 0. But the range changed. It's going less than or equal to 5 because that negative number is, that square root is becoming more negative and more negative and more negative. I'll show you on this, let me see if I can get rid of my x here. See right here? See how my y's are getting less because I'm adding a negative square root to it. Okay, see up here? If I'm adding a negative number to 5, it's going to grow less. And that's how you make sure you answer all the parts of the problem. So we'll do 11 through 17 tomorrow and have a work day on 10.2 already. Okay? And thank you for your patience with my technology trouble.